So my name's Libby Miller. I'm from BBC R&D, and I'm going to talk to you about Radiodan. You can see some Radiodans here in front of me. Okay, so the talk's called "Everyone Has a Radio in Them." So I'll just introduce briefly BBC R&D. A lot of people don't know about it. BBC R&D is 200 specialist research engineers, scientists, ethnographers, designers, producers, and we're working on all aspects of the broadcast chain. The section I'm in is called IRFS, Internet Research and Future Services, and that's about 30 people. And we work at sort of the intersection of the web and the internet and media. So our core expertise isn't electronics, although within R&D there are lots of people who have superb expertise. But within our group, our core expertise is about the web and the internet. Radiodan is a small prototyping project within IRFS. So as part of our work in this department, we work really closely with Radio Music and BBC. And what's come out of that is that we want to quickly make real-ish physical radio-like prototypes that people can use and that we can test on them. And we want other parts of the BBC, like R&M, to be able to do this as well. So why? One of the things that we're really interested in is the future of radio experiences. So within our department, outside of it, and all around the place, there are people thinking about radio. So top left is something called Alinda, which is something that my colleague Tristan commissioned. And it's a really interesting collaboration with Berg. So part of it is a DAB radio, and then part of it is a kind of a social radio part that you clip onto it. And you can envisage other kinds of things there, but this one you can see what your friends are listening to and listen with them. Below that we've got Perceptive Radio, which is commissioned by Ian Forrester, also in BBC R&D. And there it's got a bunch of sensors in it, and they've commissioned a specific piece of content that changes according to what it senses around you, things like your weather and how close you are to the radio and things like that. The lovely Lego thing is made by a Swiss company, and the idea there is that they have kits, and they have the DAB radio kits, and then they just let kids make physical devices out of whatever they like, so bits of wood, Lego, this kind of thing. And then the top right is a more sort of Internet of Thingsy type device by my colleague Jasmine Cox, and she's done a lot of research into what people really want to have, and this is a fob which you carry around. It's connected to your phone, and if you hear something on the radio when you're driving or just walking around that you want to remember later, then it just bookmarks it for you. And then there are lots of applications of radio as well, so things that go on your phone or your television or your iPad or whatever it is. So there's iPlayer radio there on the left. There's Radio Player on the right, which is all the radio stations in the UK, collaboration. Young adults typically will use applications rather than a physical device. So there's lots of people thinking about what radio might be in the future, and we've been thinking about it too for some time. So in the last few months, we've been thinking about physical prototypes and how they relate to applications and other prototypes. And speaking to academics and people in radio music and experienced designers, people working with audience feedback, there's something quite strange going on. So it appears that interacting with a physical device, as you'd expect, makes it easier to think about the functionality of the device. So, if you've got an object, you can think about what it represents and what the buttons might do, and you can interact with it. But this also seems to apply if it's a pretend device. So there's something called prototyping, Andrew, is that right? Something like that, where the famous one is the guided Palm Pilot carrying around a block of wood in his pocket and then going, I better just check my calendar. And it's completely pretend, but it gives you a sense of what sort of weight might be suitable, or what you might use it for, and whether it would be in the right place when you did. So what we found is that it also seems to elicit really interesting stuff if you just pretend that you're thinking about a physical device, which seems really quite strange, but it does seem to be the case. So I'm going to just talk you through a couple of examples about why we think this is the case now. So the first one is the arches avoider, which is something that we worked on. So as a group, we're trying to get better at electronics and physical prototyping anyway. A few of us, or all of us, attended a 2-day workshop on getting used to it. And in fact, we did a lot of shrimping it stuff while we were there. And part of the idea there was to think of something we wanted to make and then make it as far as we could. So the arches avoider, which you can see in all its laser cut final beauty here. It started off as a drawing, so you know what you can see there on the left is somebody panicking because they can hear the archer's music happening. They quickly rush towards the button, they press it, and then there's relief as something else comes on that isn't the archers. Now, I should emphasise that many people love the archers. It's just that there are some of us who don't like it enough. Anyway, so then at the top right there, you can see a kind of, well, it's called a sort of a toaster farmer prototype. So the idea there is that the farmer kind of rises up and out of the toaster thing as the arches comes on, and then you can kind of bash it down, and that changes the channel. Within the 2 days, we managed to make a sort of generic avoider, so you can avoid, you know, whatever you like. Moneybox Live is one of the things that we suggested. That's that green thing there, and then you can see this one here as well, which is me finding out about laser cutting and thinking it was a brilliant idea. So I've got a video. See if it works. Oh no. No, it's not going to work. No. Yeah.
Back to just now, and can Caroline leave Grey Gables behind? Must be the archers.
So I'll go into the kind of bits that went into it in a little while. Anyway, I'm going to talk to you about the next example first, which is talking about radios at the Bristol Hackspace. I've relatively recently become a member of the Bristol Hackspace, and I absolutely love it there. And we've had some really interesting conversations about radio there. So here's a couple of examples that people have come up with. And this got to us thinking, perhaps lots of people have ideas for radios in their heads. So this one, and they're called wrong radios, these ones, which are rather nice. This one's a time travel radio, so this is about navigating an archive, something like that. So it's kind of got categories on the left there, and then it's got the kind of, you can go back in time, so you can listen to the Archers from the 70s if that's what you want. So, and then there's this one right here, which is a bit like the Archers Avoider, but you can just avoid something like a song that you don't like temporarily, or you can avoid it forever. We've got the metadata, you could do it. And this one is an illustration of what Michael Smethurst, my colleague, calls the Rethian curve, which is the curve between learned and exciting. So you can set a place on the curve and then just have it play something. So it could be, I don't know, in our time versus, I don't know, what's exciting? Something exciting. Oh, something exciting on the BBC. Okay, so this got us thinking, can people think about devices by pretending to think about, can people come up with good features by pretending to think about devices? And the answer is yes, they can. So I've held a couple of workshops with about altogether sort of 30 or 40 people, 2 workshops. And then people I've met in the pub, or that top left one there is by a 4-year-old little girl. And it looks like a bee. And if you give people sufficient permission to start thinking about these devices, then and enough tools to make it easy for them to do it, and enough context to suggest that it could be a possibility, then you get really interesting things off them. I'll just point out a couple of them. So Matt Patterson there just wants more Melvin Bragg on any given topic, so just a button where you get more Melvin, more in our time. My friend Paul Downey's got one there where you kind of stroke the radio to say how great you think, in this case, the Today programme is. But if you press the button to say you hate it, it gives John Humphreys an electric shock. And then there's the B one, which is rather nice, and then this adapted card here which dispenses bacon. Anyway, but what we found what we found quite early on is that if you talk to, it's easy to give people these tools and talk to them about what they're interested in, and they come up with really interesting ideas. And the more diverse it is, in a way, the better. It's more interesting when you talk to lots of different people about what they want from radio, because it does vary. So, for example, that one on the bottom right is from my colleague Chris Needham, and it's about just being able to access his music collection, which might include radio streams or something like that, but it's also about his music. So there's just some more of those things anyway. We've got loads and loads of them. But what we think is that the real test will be if we can translate some or all of these into real physical prototypes that people can have a go at. So I'm kind of still thinking about this, but so this paper prototyping, which is what we've been doing, is a really good way of getting people to think about these things, especially if you give them just a little bit of context and a bit of a push in the direction of interest. And then we've got this pre-typing thing, you're carrying around your bits of wood. Typically, so I've been talking to my colleague Jasmine about this, who's got a sort of product background, and she said it's typically very good for something like a designer who's trying to get a sense of the weight and, you know, when you might use it. And then, but it's not, if you give someone a bit of wood to try, then they'll be like, you know, you've got to give them something with some functionality in it. So if we actually want to test some of these radio functions, we need to have something that works, at least a bit. So what it appears is that these physical prototypes are interesting because they're easier to understand than digital ones. Maybe it's just obvious, but if you present someone with a web page or an app, often it's quite hard for people to get a sense of what's in it and what it does. People generally like interacting with them, and they're conversation pieces. You know, if you show someone something like this, they want to hold it, they want to look at it, they want to press the buttons. And I think critically, what we learn won't just be applicable to physical radio devices, but will also be kind of backwards applicable to the kinds of applications that we're building digitally as well. So it's very interesting for those kinds of reasons. So this kind of physical prototyping can be very expensive and very slow. And so our goal here is to experiment more and guess less by being able to evolve really quickly, discard the things that don't work, test them on people, and get real feedback on ideas. So that's an illustration of some strange radios and the idea that you can just get rid of some of them. So we want to give ourselves and others the ability to gather interesting ideas, develop them using paper and cardboard prototyping, make them into real things. And we're going to start with radio because that's one of our major interests. It's also a very interesting area, and it's something that still people listen to an awful lot. So finally we get to Radiodan. So Radiodan is a prototyping platform initially for us in our department, hopefully for the wider BBC or bits of it, but it's also an open source project and has been from the start. So I said before that it was a radio-esque thing. It's not FM radio, it's not DAB radio, at least at the moment. It's just IP streams that you can make behave like a radio. So it's internet connected. It'll also play pre-recorded music. It connects to Wi-Fi. It has to be on a network in order to do anything. It can have the physical controls connected. It contains a web server, so it's very interesting trying to think about very simple user interfaces to things. But quite often you get into a situation where you need something more complex, so that's what the web interface does. And it's easy-ish to program, or it will be soon. So this is why I like it. It's an idea for generating more ideas, so it's going to hopefully get people building their own devices like this. And it's, you know, similar in some ways to what you were saying, Martin, in the sense that it's a way in for people to start exploring this area. So I'm going to talk briefly about the code. I'm not the right person to do it. My background is economics, bizarrely. I'm a self-taught programmer, but on this project, I've got a producer role, so that's the kind of project manager, product manager role. So I'm only just getting to grips with the code. My colleague Andrew is here, and he may or may not be able to answer some of the code questions you have, if you have any. But I can show you this nice architecture diagram. we're going to have a better one at some point. This is a work in progress. But you can see the main part is that there's RabbitMQ in the middle. So essentially it's a message queuing system. So you send messages to it via buttons or via the website, the web interface. They get translated into objects and serialized through the messaging structure. And that eventually controls MPD, music player daemon, which is just an off-the-shelf open source music player. So one of the real things that we really wanted to do here, partly because we're making it initially for us as a prototyping platform, but partly because there are tons of people who know how to program at least something for the web. So they know a bit of JavaScript, maybe they know a bit of Ruby or Java, or they've done some web programming, even if it's just HTML. So we really wanted to make it web developer friendly. Coming from that kind of area myself and getting into electronics, I found there's really quite a big step between knowing something about how to program and getting an understanding of the language and concepts behind this kind of stuff. So this is kind of a way in. So we're looking for easy and quick ways in for developers, especially web developers. So things like Wi-Fi connectivity can be a real pain. And so to make it easier for you to do that, thanks to our colleagues in R&M, we're allowed to use the BBC Streams and for the project, so people can have something to play straight away. But you could use other streams as well, it's just that they're there. And then a client library that works in the browser for controlling radio, so to make it easy there too. We're using Node.js because they're very fashionable. Some of the commands can be RESTful. It's because it's JavaScript, right? So if you know some JavaScript, you can make Node.js work. The commands can be RESTful calls, not necessarily, but they can be, so that just makes it easier for some people. There's a JSON data format, naturally, and there's the potential to use your own language, because we've got this RabbitMQ in the middle, so anything that talks to that could be an interface to it. It's resilient to partial failure. With some of our earlier experiments, the whole thing would come down if you made a mistake somewhere. So the idea is that we've got tested services that run independently. So if you write one, it won't bring down the player. It'll just, everything else will continue to work. So. And hardware beginner friendly. I've got a note to myself here about the barrier to entry being hard, and it is. I mean, it's been really good fun, but it's even hard to understand what the concepts are quite often, and what the pitfalls are, and what the names of things are. Anyway, so what we've gone for, what we wanted to do was not have any soldering, have just off-the-shelf components. We haven't quite managed to do that, but there's minimal soldering. They are off-the-shelf components. You don't have to buy them from China. You can get them from Maplin. You could, I think, you could at least get a sort of single button version working in cardboard without. So that I've got access to a laser cutter now, but I didn't used to. I think you could do it without anything. Maybe a crimper. Maybe that's it. Maybe that's all you need. So so we've progressed a little bit since then, but that's a picture of the inside of that white one there. Just to show you what's in it. It's a Raspberry Pi and a little speaker kit. A couple of rotary encoders. They're really cool because they light up, and they're a button as well. So we can make it so that it gives feedback about what's happening, as well as them actually being really cool. And some wiring. So it's a very, very simple thing, in fact. But it's been quite a learning experience getting it to work. One of the other things that we really wanted to do was make a case that we could adapt for lots of different radios. They're always going to look quite similar, probably, but we've got permission to open the case design up so that we'll make the DXFs available for people to use. And we've got a guy called Victor. What's his second? Victor Johansson, Victor Dons on Twitter, who's been helping us make that design useful and adaptable. So that's what we've got there. It works with lots of different kinds of materials. And yeah, it is really flexible. And he's done some really nice instructions for us as well about how to put the case together, which we're just finishing off. And I'm just going to, there's a couple of pictures of it in action. I can probably get it working later, probably. I can also just show you a quick, no, oh yeah. So what you're seeing here, you're talking directly to its own web interface. When I pressed the on button, the light showed that it was on and off. What you can see there is a bunch of different channels, and I'm just showing changing channels. And if I just scroll down, I hate the song, and it avoids it for me in a relaxing fashion and goes to Radio 3. Anyway, you get the general impression that the whole thing's pretty responsive. It's connected the web to the physical aspects of it, and yeah, it's a radio-ish. Okay, so I'm kind of winding up. So working in the open. So Internet Research and Future Services just like to work in the open. We think it's really important. We try and open source as much of our code as we possibly can. We write week notes every 2 weeks. We think the open sourceness is very important partly because we are a part of the BBC, and so we want to put back into a community that we're working in. Also for selfish reasons, because it helps the resilience and quality of our code. And for some of our projects, we've had quite a lot of contributions, and so that's really good. Not Radiodan yet. So Radiodan was different in that it was the first project that we've done that's been open source from the start, because we felt that because we weren't particularly knowledgeable within this particular area, that it was a positive thing to start from the open and then carry on there, rather than kind of chuck the code over the wall at the end. Yeah. So, last couple of slides. How close are we? Well, we're going to make a fair tomorrow, and we're not really as close as we hoped to be. The code is out there, but the documentation isn't, and we're still putting the last touches of it on, the last touches of changes on the code. We're going to put the case design up, but we haven't yet. And there's more information at that URL there, radiodan.net. Okay, my last slide is just thanks to everyone, because we've been open from the start. It's been we've had really wonderful feedback from people at the Bristol Hackspace. The top line is people from our team. There's Victor Johansson, Jasmine, Kevin and Tom helped us with electronics, Neil Ferguson with laser cutting, Bristol Hackspace guys, and everyone else. And that's it.